All right, so let's talk about some vocabulary words with division. You take a polynomial and you divide it by another polynomial. What is the polynomial called that's underneath? That would be like right here in the division. Okay, and what goes out here? The divisor.
What's the middle?
So we have dividend divided by the divisor. And what do we get out of the deal? A quotient. Now, it is possible that your divisor does not divide evenly. In that case, we get a remainder. And what do we do with the remainder?
Add it on the end.
We add it on the end over the divisor. Okay. So for the purpose of the division algorithm, which is the first thing we're going to talk about, I'm going to give these all function names. All right. So we're in our polynomials chapter. Okay. We're going to have a polynomial dividend and a polynomial divisor and a polynomial quotient. All right. So I'm going to call the dividend f of x. These are the most important. And we're going to divide by the divisor. I'm just going to call him d of x. D for divisor. Okay. When we divide those two polynomials, we'll get a quotient. I'll call that one q of x. Plus, the remainder will be polynomial, and we'll put it over our polynomial divisor. Okay. That is what's happening with each division problem. Okay. Now, I expect you to be able to perform division, whether long or synthetic. All right. But what I am most worried about as far as pre-calculus is concerned is what we can do with the long and synthetic division. Okay. So this is what we're going to talk about first. It's called the division algorithm. All right. If you look at this notation that I just wrote up here, if I wanted to talk about just f of x in terms of everything else, like I wanted f of x equals, how would I get f of x equals? How would I get f of x by itself? Multiply both sides by the divisor. And if I were to multiply both sides by the divisor, right? Hang on one second. It would cancel out here, right? We would have our quotient times our divisor, and then the divisor would cancel out here.
Don't you know how that works? I thought you couldn't multiply to things like with a plus in between them or something.
Well, we can multiply as long as we distribute all the way through. So we multiplied here, we multiplied here, we multiplied by here. So we distributed everywhere, and we did it to both sides, so we're even. Okay? This is what we call the division algorithm. It's going to appear on the next slide, so don't panic if you don't have it written down. All right? I would not write all of this down, okay? This is too many words, all right? Make sure you just have this written down. But basically, as long as your divisor has a lesser degree than your dividend, then you're going to be able to do this with every single dividend and divisor. You're going to be able to rewrite it to where the dividend equals an expression in terms of the quotient, divisor, and remainder. Okay? It's basically just rearranging the answer we got from the division. Okay? Like I said, you don't need all of these words, you just need this right here. Okay, so we're going to do a division problem, and then I'll show you what it looks like to rearrange your dividend to look like this. Okay, I would say out of the two kinds of divisions, long division is what you're probably the least comfortable with because it requires more steps. So that's what we are going to practice. Okay. I want us to divide 2x cubed minus 8x squared plus 3x minus 9 by x squared plus 1. Why am I saying that we have to do this by long division? Why do I not even give you the option of synthetic division?
Well, because I had that linear thing that he said.
Okay, good. Our divisor is quadratic, and it is not linear, which means we have to do long division.
Wait, what makes it linear? If it's odd leading coefficient?
To the first power, x to the first power. So since this is x squared, it is not linear.
So if it is linear, which means if it was like x plus 1, you could do synthetic division.
Yes. All right, there are no missing terms in our dividend, so we don't have to worry about that. Now, technically we do have a missing term in our divisor. You're welcome to write it as x squared plus 1. You are welcome to write it as x squared plus 0x plus 1 if you're worried about keeping track of terms, okay? I am not picky about the divisor, but I am picky about the dividend having to skip terms. So let's just be consistent, and I'll put in a 0x for my divisor, right? So let's just remember how we do this. X squared times what is 2x cubed? 2x. Remember to put that in the x column, and then we have to take our entire divisor times 2x. So we get 2x cubed plus 0x squared plus 2x.
And you subtract that?
We do have to subtract. Okay. Now, as for my suggestion, we're going to switch the signs so we don't have to keep track of subtraction in our head. We're just going to put the subtraction all the way through and then combine terms. So our x cubes cancel out. That's what's supposed to happen. We're left with negative 8x squared
Minus
plus x, and then we're going to bring down the minus 9. Okay? You always want the same number of terms on this next step as you do in your divisor, so we brought down that minus 9. Okay, so we have 3 terms to work with our divisor. Okay, x squared times what is negative 8x squared?
negative 8.
Okay, so we're going to take the divisor times negative 8. Okay. Like I said before, we have to subtract. Go ahead and take that subtraction through. So I'm just going to change all of the signs so that we are left with negative 1. X minus 1. Sorry. All right. So, let's write this out. We took 2x cubed minus 8x squared plus 3x minus 9, and we divided by x squared plus 1, right? That is the division problem that we did. And what we got a quotient of 2x minus 8, and then a remainder of x minus 1. So we're going to add x minus 1 over our divisor. Okay? For the first half of your homework, I would say maybe the first third. Okay, these are the kind of answers that you're going to give me, right? Quotient plus, yes.
You need.
This right here?
Yeah.
No. How about this? These are the answers you're going to give me for the first problems in your homework. All right? Now, you're going to be prompted later on in your homework to rewrite f of x, or the dividend, according to the division algorithm. Okay? So, if that was your prompt for this example, then, like we did previous, we would take everything and multiply it by that divisor. Okay? So we would have our function, okay, equals the quotient times divisor plus our remainder. Okay? And it gives us a nice polynomial instead of all of these fractions. Yes.
So when are we going to use that?
I'm not sure if we're going to see like a direct use of it in this chapter, but it's more of a way to, it's another way of writing our polynomial, okay, to where, especially since we don't have a nice remainder, right, it's just a different way of writing our polynomial. Now, if our polynomial is 0, excuse me, not our polynomial, if our remainder is 0, then we're going to use the division algorithm to factor out our polynomial. So I guess we will see it. You might not just speak of it that way. Okay? If something divides out and our remainder is 0, then we can write factor times factor. You're seeing what I'm trying to say?
Yeah.
Okay. And that's really what we're going to do here in a little bit.
Okay, what do you mean factor?
Okay? If our remainder is 0,
Mhm.
then we're going to get a factor out of the deal, and that's what we're going to talk about here in a little bit. Okay? All right. Good question. Good question. There are 2 theorems we're going to talk about. One is called the factor theorem. We'll come back to that. But first I want to talk about, it's called the remainder theorem. Okay? Now, when you do synthetic division, last night, or, well, more than likely last night you watched the video. You might have done it earlier. But you watched the video and our remainder just gave us our remainder. And then you wrote out your quotient plus remainder over divisor. That's really all you thought about it. All right? But the remainder can actually give us some information. All right? A polynomial, if we divide by x minus k, then the remainder is the function value at k. Go ahead and write it down, and then we'll talk about it a little bit more. Okay. So first of all, I see that we have a linear divisor. That makes you think of what? We can use synthetic division, all right? Some of us get a little excited about that. Okay. It doesn't matter the kind of division that you use. We're probably going to use synthetic division, but it doesn't matter. As long as we have a linear divisor, then whatever the remainder is the function value there, okay? Some of us don't really see the connection until we actually see it done with real numbers, All right, so let's do an example and then I'll re-explain it. All right. So this is what we are going to do. We are going to take 2x cubed minus 8x squared minus 3x minus 9. And we are going to divide it by x plus 1. All right, so let's switch things up. Let's use some synthetic division, all right? Are we missing any terms? Okay, so we don't need any zeros. Okay, if we're dividing by x plus 1, what number goes right here? Negative 1, all right? This is technically x minus negative 1, okay? That's in the form x minus k. All right, so let's go ahead and do our synthetic division. So we drop the 2, multiply to get negative 2, add to get negative 10, multiply to positive 10, add to get 7, multiply to get negative 7, and then our remainder is negative 16. Okay.
We learned this last year.
Now, if I was asking you for the quotient, or perform the division, whatever, 2x squared minus 10x plus 7, and then you would say minus 16 over x plus 1, okay? But what else can this give us, all right? This remainder theorem is telling us that, yeah, the remainder is negative 16, which means if this is f of x, then when we plug in negative 1, the function value is negative 16.
I thought synthetic division helped you factor it out.
It does, and we'll get there. You're a step ahead of me. Okay? The first thing that synthetic division can do is give you a function value. Okay? Now some of you are like, why would I ever use synthetic division to give me a function value? Okay? Let's say you don't have your calculator. Possible? Possible. Okay? Especially on the chapter 2 test. Yeah, you have to use a calculator. Alright? And I ask you for the function value at 5. You really want to plug in 5 to 2x cubed minus 15x squared plus 27x minus 10 and do that by hand without a calculator? Just 25 cubed. Oh, yeah, 125 times.
Sounds pretty hard.
Okay? Now, that doesn't sound completely enjoyable. We can save some time by putting this into synthetic division. Or at least, if it's not a time saver, or if you don't think it's going to be a time saver, these calculations are going to be better, right? They're not going to be as big, okay? So, find f of 5 of 2x cubed minus 15x squared plus 27x minus 10, okay? Let's go ahead and just plug this into synthetic division. Whatever our remainder is will be our function value.
What about the stuff to the left of remainder? Like the 2 and the minus 5, what do you do with that? You just keep this for
Oh, okay. Okay. I get excited when I get a remainder of 0. Why would that excite me?
Because there's one more word.
Okay, because we have a factor. What else do we have besides a factor? There's two things that we have right now. We have a factor, and we have what specifically, what kind of coordinate? We have a 0. Okay, so we have a remainder of 0. Our remainder theorem told us, well, this is your function value. Okay, so since our remainder is 0, x equals 5 is a 0. And that's exciting. Have I been putting a lot of emphasis on finding zeros the past couple days? Yeah, we're going to keep finding zeros, okay?
Wait, how does that tell if it's a 0? It's
Well, when we do synthetic division, whatever number's out here, the function value is the remainder. So at x equals 5, our function value is 0, which means it's a 0. It's an x-intercept.
doesn't seem like it would work.
Okay? Robert also said that we have a factor. X minus 5 divided evenly into our cubic function, which means x minus 5 is a factor. Which brings us to our next theorem. Our factor theorem. If we divide and we get a remainder of 0, that means we have a factor. That is what this is saying. X minus k is a factor if and only if our remainder is 0, our function value is 0.
Wait.
However you want to say it.
Can we go back one real quick?
Hold on, let people write this down.
I just don't understand how that will be the same. So basically doing that synthetic division is the same as like plugging in,
Yep.
like, we have like,
Yeah, if you did synthetic division of 3, you would get that number that you just got in front of
okay. Wait,
you. Or
synthetic.
whatever you,
Yeah, I did.
I don't know what number you plugged in, but yes. Okay, so you're going to get problems like this in your homework. Verify that x plus 3 is a factor. What kind of work do you think I would want to see if I want you to verify that x plus 3 is a factor? Synthetic division, and what should happen in synthetic division if this truly is a factor? Okay, which is why I put a smiley face, right? It gets exciting if we have a remainder of 0. All right, so I'm going to give you 60 seconds to perform synthetic division. Colby, what number goes right here? -3. X minus k, our k would be -3. I'll give you 60 seconds to perform synthetic division.
Wait, you're done?
Bottom. What remainder do we get? Bottom got a remainder of 0. Look at that. Okay, this is verifying that x plus 3 is a factor. Okay? Now, if I asked you to verify, this would be all the work that I would need. All right? However, what if I wanted, well, I would need like if I asked like, is this a factor? Explain. You would have to like write some words, right? What? Okay. Let's talk about finding the rest of the factors, okay? So, under this squiggle, I want to talk about kind of going further with this, okay? Our function, I'm going to label this f of x, okay? We know that x plus 3 divides evenly into it. And when x plus 3 divides evenly into it, we get left with 3x squared minus 7x plus 2. If we wanted to find all of the linear factors of this problem, we could go ahead and use this quadratic and factor it completely. Do you think we can factor that trinomial?
Probably.
Probably. Okay? All right. 3x squared. We know we need an x times a 3x to get 3x squared. There's no other way.
Oh, yeah.
We know we are multiplying to a positive 2 and adding to a negative number. So both of those have to be subtraction. So now it's a matter of where does the 1 go, where does the 2 go?
But why do the 3x things?
Because 3x squared.
Because I have x times 3x to get 3x squared. When we FOIL out,
Yeah.
we want to, these, okay. Ignore this guy right here. Colby, are you listening?
Yeah.
Ignore this guy.
Yeah.
These two binomials, I need to multiply to this one.
Yeah.
X times 3x would give me the 3x squared we have out in front.
I'm just saying it doesn't matter that it's in the second set of parentheses.
It could be in the
No.
first one too.
Because the commutative property tells us that the order does not matter. Okay? All right, so where does the 1 go? Where does the 2 go?
She goes in the first one.
Wait, where did you get a 1 and a 2 from?
He's almost was in the two.
We need to multiply to 2, and the only way to do that is 1 and 2. Okay? So negative 2 times 3x would give us negative 6x. X times negative 1, negative x. Those add to be negative 7x. That would FOIL out correctly. Okay? So, we divided out x plus 3, and then we can factor what was left over to get all of the linear factors of that problem. Okay?
Wait, so that one on the right means that one of the zeros is 1/3.
Yep. If we wanted to talk about our zeros, they would be negative 3, 2, and 1/3. Yeah. If you know a zero, you know a factor. If you know a factor, you know a zero. Okay? Kind of nice, right? All right. Don't write this down because you already have it written down in 2 different places, okay? But this is just a reminder. If we know the remainder, we know 3 things. Well, the remainder gives us the function value. If the remainder is 0, we have a factor. And if the remainder is 0, we have an x-intercept. We have a 0. Okay? Now, we have kind of an awkward amount of time left. I know if I stop right now, you're not going to start your homework. So, I would like to point out one type of problem that you could see in your homework this evening. Okay? Okay, so here I'm giving you a 4th degree function, and I'm telling you x plus minus 5 and x plus 4 are factors, but I want all of the linear factors. Okay? What should we do with x minus 5 and x plus 4?
You have to like divide them both, like,
Okay, we would want to divide them, and what you're trying to say,
and then they're like you like keep going.
yes, and you keep going. So we can use synthetic division because we have our linear divisors. So 1, negative 4, negative 15, 58, negative 40. Okay? So let's just start with the first one that we have. If x minus 5 is a factor, we know that 5 should be a 0, right? So bring down the 1, multiply to 5. Add to 1, multiply to 5. Add to negative 10, multiply to negative 50. Add to 8, multiply to 40. And there you go. We have a 0. Now, Colby, can you be a little bit more specific as what you were saying earlier?
I don't remember. Well, I kind of do. It's like the rest of the answers that we have there, like 1, 1, negative 8, we synthetically divide that by 4. Like
Okay,
by
good.
negative.
Right. Don't take a step backwards and go to your function, okay? We already divided out x minus 5. And with whatever is left over, our next factor should also be able to divide into if it's already a factor for the original one, okay? So instead of going back to the original one, we can do synthetic division again on what we factored out. Okay, so let's do that. We drop the 1. We have negative 4. Add to negative 3. Multiply to 12. Add to 2. Multiply to negative 8. Good. We got a 0 again. Okay, I'm hearing people say, I think we did this last year. Probably did. So now what we have is x minus 5 times x plus 4 times what we have right here, x squared minus 3x plus 2. Now with our knowledge of quadratics, we know that that factors to x minus 2 times x minus 1. And now we have all of the factors for our polynomial. Okay? Now, some of you might be thinking, oh gosh, I remember when we had to try these different numbers in synthetic division, and sometimes they worked and sometimes they didn't. You know what I'm talking about?
Nope.
Okay, that's what we're doing on Friday. So that is coming. All right? It's one of my favorite things to do. Okay? All right. On your gold sheet, you have homework from page 144. Okay. The first few will be just straight up division problems, and then you'll get more into the factors and verifying factors and the factor theorem and that kind of stuff. Okay? Tomorrow, you will get a review for your quiz Thursday. You'll also get a problem set. In class, we are going to talk about some material that will not be on the quiz, but it's material that you talked about in Algebra 2, so we're going to do our lesson a little bit differently tomorrow. So that's just kind of your warning. Okay?